Welcome to section 7.2. Today we're going to multiply and divide rational expressions. Okay, so we're going to start with just reviewing multiplication of regular fractions first. So here's two fractions, 5/5, and we want to multiply that times 8/3. So multiplying fractions is pretty easy. You just multiply across the numerators, so 4 times 8, and you multiply across the denominators, 5 times 3. So you get 32 over 15. However, see what I just did there is I multiplied before simplifying, which now makes this simplifying this a little bit harder. So what I actually recommend that you do is to simplify first. So while we're at this step, let's see if anything simplifies. Okay, and in this case it actually happens that nothing does because 4 and 8 have no common factors with 5 or 3. But it's important that you look at it at that step before you multiply together to try to simplify. Well, it makes it easier on yourself. Okay, so but you multiply across the numerators and across the denominators. That's the main idea. So when you multiply rational expressions, of course the rules are the same. You multiply across the numerators, so in the numerator here we'll have x minus 4 times x squared minus 9, and in the denominator we'll have x plus 3 times 2x minus 8. Okay, now at this step, while it's factored, let's go ahead and simplify. Okay, there's no reason to expand because remember, then you can't see if it's simplified or not, and really there's no reason to expand anyways. So let's see. We want to see if anything else factors. The way it's written, nothing cancels yet. So x squared minus 9 factors further. That's a difference of squares. So that factors into x plus 3 times x minus 3. And in the denominator, we can factor 2 out of the 2x minus 8. You're left with x minus 4. Okay, and at this step, it does appear that some things cancel. X minus 4 over x minus 4. And x plus 3 over x plus 3. Can't see that yellow there. There it is. Okay, and so we are left with x minus 3 over 2 as the simplified version of that product. Okay, let's do a few more. Okay, well, in this one we have 16y times 1, so I'm just going to write 16y in the numerator, and 3x squared in the denominator. Nothing cancels, so that's it. Alright, on the next one here, let's see, we have, now this negative, remember, can go either in the numerator or the denominator, or you can just leave it out front of the whole thing, which is what I'm going to do. So in the numerator, we're going to have 5 times a cubed times 2 times b squared. So I'm going to go ahead and multiply that together as 10 a cubed b squared, although you may want to leave it as 5 times 2 to make it easier to simplify. And in the denominator, we have 3 times 15. I will leave that one as 3 times 15 just for the moment. Times a times b cubed. Now I reordered things, as you can see, because the typical order is the number first and then the variables are in order, well, in alphabetical order. So that's why I reordered, but you don't have to do that. And let's see, simplifying. Okay, the numbers on simplifying these coefficients here, 10 breaks down into 5 and 2, and 15 breaks down into 5 and 3. So we can take a 5 out of the 10 and out of the 15. And we have an a cubed divided by a, so one of those a's will cancel with this a in the denominator, leaving us with a squared. And b squared over b cubed, so 2 of the b's cancel, leaving us with b to the first. So we're left with 2 times a squared over 3 times 3, or 9, times b. So there's the simplified product. And let's do one last one on this section here. Okay, now as I multiply across, I'm also going to factor at the same time so that I don't have to write as much. So I'm going to multiply these numerators. Now at the same time, let's factor. Out of the 4x plus 8, I can pull out a 4. So I have 4 times x plus 2 times this numerator over here. And let's see if it factors. It may or may not, we'll find out. 3x squared we'll have to factor into 3x and x. 2 we'll have to factor into 2 and 1. The question is just, did I put them in the right place or not? I don't think I did, because those are not going to add to -5. So let's switch. Let's put 1 and 2. And let's see, if I put the negative in front of the 2 and the positive in front of the 1, it looks like that'll work. So we'll get 3x squared. My outside terms will be -6x. My inside term will be plus x, which does add to -5x. And then my last term is -2. So that works. And then in the denominator, we have 14x minus 7x squared. So out of that, I can factor out a 7x. I'm left with 2 minus 7, 2 minus just x, times, and this denominator here, 9x squared minus 1. Well, now the way it's written, it cannot be factored, and I can't factor a 9 out of each term, but it is looking suspiciously like a difference of squares, and in fact it is one, because 9 we can rewrite as, switch colors here, 9 we can rewrite as 3x all squared. That's the 9x squared, but I'm factoring that square out. That way, now I can rewrite that on the next step as a difference of squares. So at this step, before we do that, let's see if anything cancels. And it looks like we have an x minus 2 and a 2 minus x, which are close. So all we need to do is factor out a -1 from one of those. And I believe that's all. Nothing else cancels at this step. So then coming down here, I'm going to rewrite everything else. And I'm going to factor a -1 out of this x minus 2. Now typically when you write a negative, you put it at the front of the whole thing, which is what I'm going to do. So this negative is going to come out of that x minus 2 there. Then I'll recopy the 4, the x plus 2, and the 3x plus 1. And then after I factor that negative out, I'm left with -x plus 2. In the denominator, we have 7x times 2 minus x. Okay, all times, now this 3x squared minus 1, we'll factor into 3x plus 1 times 3x minus 1 by the difference of squares. Now this is definitely fully factored, and let's see, we have 2 minus x and 2 minus x, really, if you reorder those terms, so those cancel. We have 3x plus 1 over 3x plus 1, so those cancel. And I believe that's all. So we have -4 times x plus 2 all over 7x times 3x minus 1. Now I know a lot of you often have tendencies to want to expand, which you can do. I just see no reason to do that here, to expand. People often have the notion that expanded means simplified, and that's not really true. A factored version is often more simple than an expanded version of something, so really I think it's completely fine to leave that factored right there. Because again, if you expand, you might mess up, so better to just take less steps and not risk making any mistakes. Okay, that's it for multiplying rational expressions. It's fairly straightforward. Multiply across the numerators, multiply across the denominators. So that's all we're going to do there. Well, now let's divide a few rational expressions. Okay, remember when you divide fractions, you actually multiply the first fraction by the reciprocal of the second fraction. And the reciprocal means to flip it upside down. So what you do is you change that division sign to a times, then we flip the second fraction, so it becomes 7/6. And then we multiply. So then 7 times 3 is 21, 2 times 6 is 12. But I'm not going to multiply yet because I can simplify here. A 3 and a 6 have a common factor of 3. And that's it. So we have 7 divided by 2 times 2, or 4. Okay, with rational expressions, the process is exactly the same. So here we have 7x squared over 6 times 2y over x. Now you definitely need to multiply by the reciprocal, in other words, do this step right here, before you start simplifying. Because if you try to start canceling factors at this step before you multiply, you'll be canceling the wrong factors, because see, in reality here, it doesn't look like any x's will cancel because you have x's in the numerators of both terms. However, once you flip that second fraction, this x goes to the denominator, so it will cancel with one of those x's. And the 2, we can take a 2 out of the 6 as well. So we are, and at this step, I know you know that you're going to multiply across and multiply across, so you don't have to write them all over one bar before you simplify. So at this step, you can actually go ahead and start simplifying once you get the hang of this. So I'm going to take a 2 out of the 6 and the 2, I'm left with 3. And then the x squared and the x, the square cancels with the x. So we are left with 7xy over 3 after we multiply. Okay, let's do another one here. So first thing is to see if anything else factors, and it looks like on the first fraction, nothing else factors. So we have 2x plus 3 times x minus 4 all over 6 times the reciprocal here is 2 over 3x minus 12. And now let's see, on the second fraction, I did not simplify anything yet. So let's see if anything simplifies there. We have 2x plus 3 times x minus 4 times 2. So I'm going to actually bring this 2 out to the front when I multiply these together. And then in the denominator, we'll have a 6 times, I can factor a 3 out of 3x minus 12. So I'm left with x minus 4. And now things are starting to cancel. We have 2 over 6 is 1 over 3, and x minus 4's cancel. So we are left with 2x plus 3 over 3 times 3, or 9. Okay, let's do a couple more, just to make sure you've got the hang of it. So first thing is we're dividing by here, so we're going to multiply by the reciprocal of that fraction. At the same time, I'm going to start factoring, just so I have less steps. So this 3x squared minus 10x plus 8, we'll try to factor that. And we'll have times the 21 over the 9x minus 12. I can go ahead and take a 3 out of 9x minus 12, and I would be left with 3x minus 4. So I'm now multiplying by the reciprocal, and I factored in one step. And on this, let's see, 3x squared minus 10x plus 8. So we'll have a 3x and an x. Let's see, let's give this a try with breaking the 8 into a 4 and a 2. I'm going to try putting the 4 on the outside so that it will multiply with that 3x to give me a 12, and the 2 on the inside. Now I want to get negative 10x when I add, so I'll put the negative in front of the 4 and the positive in front of the 2, so that for my inside and outside terms I get 3x times negative 4, or negative 12x, plus 2x, which is negative 10x, so that works. And in the denominator we can factor out a 7, so we're left with 7 times x minus 2. Okay, and now we are multiplying, so we can go ahead and start canceling. Let's see, 21 over 3 simplifies into 7 over 1. And then after we do that, then we have a 7 divided by a 7. So those are going to completely cancel. And it looks like that's it. Nothing else is quite the same, so nothing else cancels. So we just have 3x plus 2 times x minus 4 over x minus 2 times 3x minus 4. And that's it for that one. And one last one here. Okay, to make sure you're trying these on your own first. This one, if you don't forget to multiply by the reciprocal first, you might try to cancel those x plus 3's factors. But don't forget to multiply times the reciprocal of the second fraction. And as you see, the x plus 3's are both in the numerator, so they don't actually cancel. So that can be written as x plus 3 all squared over 7x. That's it for multiplying and dividing rational expressions. Tune in next time for section 7.3.